A very good day to everyone. In this video, we will presenting MAT183 Calculus 1 of Chapter 3, which is Application of Differentiation. The subtopic that we will talk about is Rolle's theorem and mean value theorem. These are the group members. Based on the picture from left to right, the group members are Emirencia, Benicia, Evelyn Marcia, and Daniela Eugenia.
There is a lot of usage in application of differentiation, either in our daily life or even in math lesson. Frequently, it is used to determine the maximum and minimum values for a particular points like cost, amount of materials, and even profits. This application always been used by engineers or even government for them to count the population of humans. In math lesson, the student use the application to determine the maximum or minimum values that are saddle points of a function. They also can determine the concavity and convexity of a function. Lastly, they can obtain a tangent and normal of a function at a certain point.
The subtopic in the Chapter 3 of Calculus 1 MAT183 are use derivative form as dy over dx, related rates, analysis of function 1, analysis of function 2, maximum and minimum values, applied maximum and minimum problems, Rolle's theorems, mean value theorems. The purpose of Rolle theorems is to identify a point within 2 points of the interval where the function derivative will be equal to 0. There are many examples of application in daily life, which are to determine the maximum value of complex graphical function and to construct a curved dome of a building. Besides that, the purpose for the mean value theorem is to determine a point within 2 points of the interval where both the slope of tangent and secant line are equal. The example of application in daily life of this theorem is to testing the accuracy of speedometer.
How exactly are we supposed to use these theorems? Well, there are few conditions we need to consider before applicating these theorems into a question. First of all, Rolle's theorem states that if the function fx is continuous on closed interval ab, and if fx is differentiable on open interval ab, such that the function fa equals to fb, then there is at least one point c within the open interval ab such that f prime c equals to 0. Whereas the mean value theorem states that if the function fx is continuous on closed interval ab, and if fx is differentiable on open interval ab, such that the function fa does not equals to fb, then there is at least one point c between the open interval ab such that the function f prime c equals to fb minus fa divided by b minus a. The first question is to find all the values of c in the given interval that satisfy the conclusion of Rolle's theorem. The function is fx equals to x squared minus fx plus 4 with interval 2, 6.
To solve this Rolle's theorem question, we will first determine the value for a and b from the interval. We need to remember that the smallest value will be picked as a and the largest value will be picked as b. Thus, for this question, a is equal to 2 and b is equal to 6. Secondly, we will need to substitute the value a and b into fx. The function fx given in the question is fx equal to x squared minus fx plus 4. When we substitute the value a, which is 2, into this function, we will get the value negative 8. When we substitute the value b, which is 6, into this function, we will also get the value negative 8. Thus, if fa is equal to FB, the F prime C is equal to 0. Thirdly, we will need to find the F prime X and F prime C. From the question, Fx is equal to x squared minus 8x plus 4. We will need to use the power rule to solve this question. Thus, f prime x is equal to 2x minus 8. To find the f prime c, we just need to change the x into c. Thus, the f prime c is equal to 2c minus 8. Lastly, we will need to find the value of c. F prime c is equal to 0 and f prime c also equal to 2c minus 8. When 0 is equal to 2c minus 8, the answer will be c equal to 4. In conclusion, c is equal to 4 and this value satisfied the interval 2 to 6.
The mean value theorem states that if fx is continuous on a closed interval ab and differentiate on the open interval ab, then there exists a number c in the open interval ab such that f prime c equal to fb minus fa over b minus a. If fx equal to x plus 1 over x, find the value of c in the closed interval 1 over 2, 2.
There are several steps that we will need to do to solve this question. Firstly, we will determine the value of a and b from the interval given. From here, we can see a is equal to 1 over 2 and b is equal to 2. We can always say we pick the smallest value for a and the largest value for b. Secondly, we will need to find the fa and fb. We just have to input the value a and b into the function fx equal to x plus 1 over x. Thus, in the end, fa is equal to 3 and fb is equal to 3 over 2. Thirdly, we will need to find the f prime x and f prime c. From the function given, we know that fx is equal to x plus 1 over x. Thus, we will need to use quotient rule to solve it. From the function, we know that the numerator u is equal to x plus 1 and the denominator v will be equal to x. Thus, when we differentiate u, we will get du over dx equal to 1 and differentiate v, we will get dv over dx equal to 1. We just have to input this value into the quotient rule formula, which is f prime x equal to v du over dx minus u dv over dx over v squared. We will solve as usual, and in the end, f prime x is equal to negative 1 over x squared. To find the f prime c, we just have to change the x into c. Thus, in the end, f prime c is equal to negative 1 over c squared. Lastly, we will need to find the value of c using the formula given from the question, which is f prime c equal to fb minus fa over b minus a. We just have to input the value we have gotten before into this formula. Thus, in the end, we will get the value c equal to plus minus 1. We can also written this as c equal to negative 1 and c equal to 1. In the end, we have chosen the c equal to 1 as it satisfies the interval 1 over 2, 2.
In conclusion, the Rolle's theorem is a special case of mean value theorem in differential calculus because it is used to prove the mean value theorem. Both theorems show that the value of c lies in the interval and even provide the accurate information of its position and location.
We are really grateful for our group members for finishing this assessment tree for MAT183 successfully. We are also thankful for the guidance from our dearest lecturer, Madam Rumaiza, during the process of finishing this within due time.